my name is Michelle, and I wanted to learn how to write VHDL code. And so it was suggested to me, since the most basic thing that happens in an FPGA is that you would write to registers to configure the FPGA. You read and write from registers. And so therefore, I was told that it was the best way to learn is to write an AXI master driver that interfaces with like an AXI BRAM. And so that was my first, that's how this project started. So sure enough, I wrote a test bench that allowed me to, and here's my test bench, and you can see where I'm sending out addresses. I'm using some strobes, which is an AXI thing. And I'm even putting in some data that makes to test the strobe. And then here's my read from whatever I did. You can see that my output, my addresses are here, and here's my outputs, and they're what we should see. So the test bench definitely works. So which basically proves that the code that I wrote works. Now, admittedly, like I said, I was using an AXI BRAM. So we'll go look at the BRAM, and you can see that where there's write logic for the writing the address. Here's the writing of the address, and here's the nice. It's getting the information that's required, nice and tight. You'll see tight. You can see tight up here, maybe, but you'll see better when I show my master. And then here's where we're writing the data. And so we're using bursts. This was a single burst, a single burst. This is a 2 burst. This is a 3 burst, and then this is a single burst. And so you can see that this is the AXI BRAM, which is an IP. I did not write this. This is an IP. And so you can see that it's getting the data like it's supposed to. And then, of course, when we go to read from it, you can see that sure enough, we're reading from it each individual address. And then here's the data, and the strobe is working properly. The data, all the data I was looking for went in. The only thing right here where you can see some zeros, now I'll explain that in a minute. Well, actually, this one didn't have anything written there, but I'll explain something in a minute when I go to describe the masters that I'm writing. But you can see basically this is, so whatever's interfacing with this BRAM, it's getting the proper data like it's supposed to. Oh, by the way, this 0 is because we didn't write to that address. That's why there's a 0 there. Oh, well. So let's go ahead and recompress this again so that we can get back to our lists. We'll compress our BRAM small. So there's 2 masters in here. Like I said, here's my test bench. There's 2 masters. One, this master here, master 2, goes to the BRAM. And just in the short, I didn't like separate anything out here, so you can just see that I'm sending the addresses, that I'm sending the data, and then that I am reading. This is my output going to my test bench. Down here's my read. I'm reading from my well, does it? Yeah. Oh, down here's the read. I don't know why it's in twice. That's interesting. Um, here's my addresses right here, and then I'm getting the data out like I'm supposed to, and it's just showing my states and things like that. So I was using state machines to be able to do the logic, and then different type bursts, so you can do burst counts and things like that. And so actually I've had this previewed, peer reviewed, and people really liked my code, and they really liked how tight things were, and they said this was very good work. So I'm proud of that, and I hope that somebody ever wants to hire me and they're looking at this, that they might say agree, and this be like the thing that says, oh yeah, we're interested in hiring her because she can write really good tight code, and she does good namings and things like that. It's all in this. If you look, you can slow it down and look at the names that I put. Oh well, so this master here, I did break it down for you. So basically I have the address. So that's coming from the test bench. It's telling me I want these addresses 0, 4, 8, 10, and 20. Notice we skipped an address. And then we had a single burst, 2 bursts. Well, these are addresses, so you can't see it. Let me go ahead and get my rate showing so you can do the burst. You can see, so here's the data that we're sending in, and we have our, like I said, single burst. Here's two bursts. Here's three bursts, and then another single burst. And then these are our lasts. Where's my last here? So here's my last signals. So my lasts are in the right place. Here's my strobes, so you can see that I'm strobing the data, which I'm getting rid of that part. And if you look at this one, I have another piece of information in there that we're getting rid of. So you can see that the output is correct based on the strobes, based on the bursts and things like that. Um, and then of course you can see now on the read, the reason why this master is going to my AXI slave. Now I want to hold off on the read on this master for a minute. So let's go do that. Let's go take a look at that. So we did our write and our address. We'll come back to our read in a minute. So the slave that's getting from that master, here's our write. The data is coming into my slave. It's negotiating and getting the addresses like it's supposed to. And of course, it's communicating and it's getting the data from my AXI master. So I'm getting the information. But what I'm sending this out to is a native regram, which you'll see right here, my native regram. And if we come in here, you can see I'm telling, here's my strobe information I'm sending to it. Here's my data, my addresses and my data. However, it turns out that the regram doesn't do any kind of burst logic. So therefore, when you see that we're putting in the bursts, however, when we read out of this regram, we're not getting the bursts. There's zeros in here. And like in this case, it's missing the 60 because 61 was the last one, and that just happened to be the last one while it was valid. Here, we're missing the 70 and the 71. Here's our 72. And of course, that was the last ones that we didn't write to. And then, so it didn't have burst logic. So what I probably need to do now is probably add some logic in my slave, AXI slave, which I'm not 100% sure if that is true to an AXI slave, to do to literally increment addresses for bursts when you're in a non-native mode. And I don't know the answer to that question, but I mean, I can obviously go in and do it. But the point of this video is to show that I have coded these things. They are working. Data is as expected, given that this again is a rich RAM. And that's also an IP that I did not write. And so now let's go back to our read, because this is the slave and it's sending it in. So it got from the master to the slave, wrote it to the reg RAM. Now we're reading from the reg RAM from the slave. And you'll notice we have our 58, 59, 61, 0, 72. So we're getting the proper data from the slave that is in the slave because it didn't do bursts, which we go back to our master, which is, remember I said I wanted to hold off on that. And we look at our read on our master that we're getting from the slave. And sure enough, we're getting the same thing back to our master. So our master and our slave did communicate properly for the read as well as the writes. And so therefore you can see everything's nice and tight. You can see my state machines, which, I mean, if you went in and looked at them, I got my address, my idle address. This is probably data. Yeah. So all my state machines. And then of course, obviously we're back to the beginning where we show, and I'm going to minimize all this stuff again, our test bench, which now again, this is the test bench went to the master and then to the BRAM and then back to the test bench. So therefore our read shows our addresses and of course our data, which is correct. And so basically this is, I coded all the master driver and I coded the slave driver. And then of course the test bench to make this happen. And so I hope you like this video, and I hope it helps you see the value of how I code, the naming conventions I use, the strategy I'm using, the states that I'm using, and it shows that I am a good VHDL coder, which I do believe would make me a good FPGA designer. Um, my timings are really good here. And so This is just to illustrate my abilities. So thank you for your time. I hope you enjoyed the video.